Let's come back to CBC 2 chemistry class. So hope you have revised the topic oxidation numbers. That is basically we are under a discussion of basic concepts of mole concept, basics of mole concepts. Under that the homework for today is DPP 15, and also we will be discussing the further concept from oxidation numbers, the second part of mole concept topic. Okay na? So going to this DPP 15 homework discussion, and this you see, as you are at home, there will be no teacher to check you whether you have done or not, but this is our minimum responsibility, like whatever the very important bridge course is going on, that to be made perfect for yourself, right? So when you do like that, only the next 2-year journey will be smooth. It will not only make you learn stronger in concepts, but also this CBC program at home, how you are doing, will teach you or will make you understand what is your inclination, what is your seriousness for the program, right? So make it good and happy from starting onwards, that the entire 2-year journey, right, will go very smooth, very happily, right? And we are all there at the campuses to make the program successful. So definitely put all your efforts. We are all there that you can reach to your destination dream colleges, right? So let's get into DPP 15 discussion. 0.5 moles of electrons contain. 0.5 moles means how many? That is what he is asking. We know that 1 mole means Avogadro number, right? Na? Then 0.5 moles is how much? Half. Na by 2. Understanding or not? So next question. Na by 2 means option A. So is it given correct? Right. Next. How many atoms of hydrogen are present in 49 grams of sulfuric acid? We know sulfuric acid, if you remember, in the last lecture also we have discussed, we have calculated its gram molecular mass. Gram molecular mass of sulfuric acid is 98. 2 plus 32 plus 64. 98 grams. So if 98 grams is 1 mole, then 49 grams is half mole, right? Now, so they have given us 49 grams. That means half mole or Na by 2 H2SO4 molecules. Na by 2 H2SO4 molecules, not hydrogen atoms. Na by 2 sulfuric acid molecules. Now, each sulfuric acid has 2 hydrogen atoms. Then, Na number of sulfuric acids will contain how many? So, Na by 2, sorry. So, one sulfuric acid molecule has 2 hydrogen atoms. Then Na by 2 moles of sulfur, Na by 2 sulfuric acid molecules will contain how many? Double Na. So, Na by 2 into 2, that is Na hydrogen atoms, right? Understanding na? So, Na hydrogen atoms. That's it. Very simple. Next, the sum of the number of hydrogen and oxygen atoms present in 3 moles of water molecules. 3 moles of water molecules. In 3 mole water molecule. First of all, let me check it for 1 mole. H2O na? In H2O, how many moles of water molecules are there? Let us assume in 1 mole, how many moles of water molecules will be there? 2 mole hydrogen will be there and 1 mole oxygen will be there. When 2 moles of hydrogen is hydrogen atoms, when 2 moles of hydrogen atoms is combined with 1 mole of oxygen atoms, you will be getting 1 mole of H2O molecule. 1 mole of H2O molecule. Right? So, in this manner, if you see, then in 3 mole H2O. How many moles will be there? In 1 mole, 2 moles, then in 3 moles, 3 into 2 moles. That is 6 mole hydrogen and 3 into 1. 3 mole oxygen atoms. 6 moles means 6 Na and 3 moles means 3 Na. So total oxygen plus hydrogen is equal to 3 Na plus 6 Na, that becomes 9 Na atoms. You cannot distinguish which atom they are. They are oxygen plus hydrogen together. So 9 Na atoms are present. Where is the 9 Na? Option A itself is perfect here, right? So 9 Na. I think in your key it might be given as a C. That is what we have checked it, but the key mistake is there, that you can see here in 3 moles, 6 moles of hydrogen is there and 3 moles of oxygen is there. So 6 plus 3, total 9 moles of atoms are there. Each mole is 1 Avogadro number, we have already know. So 9 into Na. So key mistake is there, please aware of it. The mass percentage of hydrogen in H2O is, the mass percentage of hydrogen in H2O is, in H2O, first of all, H2O gram molecular mass is 18 grams. In this 18 grams, 2 grams is of hydrogen and 16 grams is of oxygen. He is asking how much is this 2 grams among the 18 grams. That is what the mass percentage. Mass percentage formula is, mass of hydrogen divided by mass of H2O into 100, right? I am assuming that it is of given 1 mole, right? In 1 mole, I am assuming that so that I can take it as 18 grams. So mass of hydrogen is 2 divided by 18 is the mass of water when I take 1 mole, right? 1 mole into 100. Okay. So how much will come? That you can calculate it and can get it. 18 5s 90, 10 point something should be there. So option A should come to the answer. Maybe I am doing a rough calculation. You can do the perfect calculation and can recognize what is the perfect answer. But here nearer answers are not there. That is much more better here. Like in a NEET, the question is given. But in a JEE, it will be like 10.5, 10.8, 11.1, 11.3, like that, very closer, very nearer values will be given, that you need to do a perfect calculation, then only you can reach to the perfect answer, right? And also integer type questions, right? If you see the JEE Advanced 2025 paper, live discussion we have done, right? In that paper, if you go through, in paper 1, there are 6 integer type questions and in paper 2, there are 8 integer type questions. So total 14 questions are there out of 32 questions, integer type or numerical based type of question. What is that numerical based type of question is, they don't give the options. They just ask the mass percentage of hydrogen in H2O is dash. Like a fill in the blanks in your childhood, in your school sessions, right? So what we have to tick mark here is whatever the integer you will be getting or numerical value you will be getting. Sometimes integer means like a 10 or 11 or 12 like, but when it comes to numerical value, 10.59 has to be bubbled perfectly as it is, 10.59. Like that the question, majority of the questions were there. So very accurate in calculations only can make us to get the perfect answer there. Okay na? So going to the next question, how many moles of oxygen atoms are present in 12.26 grams of KClO3? KClO3, right? First of all, there is no need to have the concern also. Molecular mass is also given. You need not calculate it. So 122.6 grams is 1 mole KClO3 122.6 grams is 1 mole KClO3, right, which will have 3 moles oxygen. Yes or no? Because of each molecule has 3 oxygen atoms. Each molecule has 3 oxygen atoms. So like that 1 mole molecules are there. So 1 mole into 3. So 3 moles of oxygen atoms will be there. But what he has given is 12.26 grams only. 12.26 grams is a 0.1 mole KClO3. So which will make it as a 0.3 mole oxygen, or you can also write it as in Avogadro number also we can write 0.3 Na oxygen atoms, right? But he is asking in terms of moles only, so you can easily mark it option B. So fifth question, option B. The number of atoms present in 2 moles of phosphoric acid. 1 mole phosphoric acid H3PO4. 1 mole phosphoric acid has 3 mole hydrogen 3 mole hydrogen plus 1 mole phosphorus plus 4 mole oxygen, right? That means total how many atoms are there in 1 mole? 3 plus 1, 4 plus 4, 8 moles of atoms are there. All atoms together it is 8 moles. Now he is asking in 2 moles, that is a double. Then in 2 moles, how many will be there? 2 into 8, that is 16 moles. Understanding enough? 16 moles will be there. 16 moles or 16 Na. Next question. How many times an atom of sulfur is heavier than an atom of carbon? How many times an atom of sulfur is heavier than an atom of carbon? Here you should assume that sulfur 16 only he is talking about and carbon 12 only, right? He is not specifying which isotope he is taking. Therefore, the general most stabilized normal isotope only, common isotope only we have to consider, right? So, and do you remember what is he asking? He is asking about relative atomic mass, RAM. He is asking about the RAM, yes or no? So, in the starting of this chapter we have discussed what is the RAM, AM, then GAM, etc., right? So, RAM is how many times sulfur is heavier than carbon? Sulfur is 32, carbon is 12. So this is 12 3s are 36. So but it is the value is little lesser than 36. So it should be, the value should be little lesser than 3. But it is not given. 32 times wrong, 12 times wrong. Yes, this is also wrong. This is less than 1. 12 by 32 means it is given actually reverse. Then here it can be considered 8 by 3, 8 by 3, 2.8 by 3 means how much you will be getting? 2.666 like that you will be getting 2.7. So here okay. So, or else with the 4 table you do it 4 8s are 32, 4 3s are 16. So, straight away also you can do it. Actually, they don't give in this much simple way, right? Understand one thing, they don't give in this much simple way, they give in strong calculations only, right? So, you should be ready with that and do it. gram atomic mass of calcium is 40, the number of moles in 60 grams is, right? Among the 60 grams, in a different way I am telling, see, 40 grams is 1 mole, then remaining 20 grams will be half mole. So this is what total 60 grams, na? So this total will become 1.5 mole. Option C. Then coming to number of moles of 0.64 grams of sulfur dioxide is 64 grams, or I can say like number of moles. So what is the formula for a number of calculating number of moles? Number of moles is equal to 0.64 divided by 64. So this becomes 10 to the power of minus 2, na? So that is a 0.01. That's it, right? Then coming to number of molecules in a 4.25 grams of ammonia. I think this question has already come also for us, same question to what I remember, and it is 17 by 4.25, that is 4, right? 1 by 4. So number of molecules in 4.25 grams ammonia, number of molecules is mass by molecular mass into Avogadro number. Mass by molecular mass will give you moles, right? Number of moles into Avogadro number will give you molecules. So mass is 4.25 divided by molecular mass is 17 grams for ammonia. 14 plus 3, 17 grams, right? Into 6 into 10 to the power of 23. So this becomes 4.25 ones, 4.25 fours. So 1 by 4. So 2, 3. 3 by 2 means 0.5. 1.5. So 1.5, yes. The option was also same, right? So it was option A, right, at that time. So same is the thing here also. 1.5 into 10 to the power of 23 ammonia molecules are present. Right now, the next quickly let's discuss the next remaining questions also and go to next chapter. The atomic mass of calcium is 40. The number of calcium atoms in 0.4 grams. This is also similar type of question. Number of calcium atoms is equal to, first I will calculate number of moles, that is by 0.4 by 40 into Avogadro number of calcium atoms, right? So this will be 10 to the power of minus 2 into 6 into 10 to the power of 23. That is 6 into 10 to the power of 21 calcium atoms. Yes or no? 4 into 10 to the power of minus 1. So 4 by 40 means 1 by 10. So 10 goes up, 10 to the power of minus 1 already is there, another 10 to the power of minus 1, 10 to the power of minus 2. So 6 into 10 to the power of 21. So is it a given 11th question, option D? Right? Then next, the atomic mass of oxygen is 16 and the molecular mass of ozone is 48. What is the atomicity of ozone? Atomicity, if you remember already I have explained you. Atomicity, if you remember already the definition we have seen. What is it? Atomicity indicates how many atoms are present in one single molecule. Number of atoms present in one molecule is atomicity. Number of atoms present in one molecule is atomicity, right? So number of molecules, number of atoms present in one molecule is atomicity, right? So here molecular mass of ozone is given 48 and ozone means, in ozone Directly also we can write, but according to the question, let us try to answer. That is the reason why I am not writing its formula. Otherwise, I know the formula that just by seeing the formula, right? N2 molecule is there, atomicity is 2, Cl2 molecule atomicity is 2, helium atomicity is 1. So like that we can say, but according to the question, what concept he has given, let us see, accordingly we will take it. Ozone molecular mass is 48. And within ozone, what will be present? Oxygen atoms only, na? Oxygen atoms only are present. Now, these oxygen atoms, how many are there that it will make up to 48? And each oxygen atom, what is the mass? 16. So, 16, each oxygen atom is 16. That how many such oxygen atoms should be there? So, how many such oxygen atoms should be there? By now, I think you might have understood atomicity is molecular mass by atomic mass. Yes or no? Molecular mass is 48 and atomic mass of that atom which is present in the molecule is 16. 16 ones, 16 threes. So, 3. Therefore, O3, ozone molecule, O3, right? Na? So, option C is the answer. Then going to the next question, number of oxygen atoms in a 4.4 grams of carbon dioxide is approximately, same concept we are taking, 4.4 grams carbon dioxide, right? 4.4 grams carbon dioxide means how many moles? 0.1 moles, na? By now, can you guess it directly? Can you tell it directly? 0.1 mole carbon dioxide. How it is a 0.1 mole carbon dioxide? It is by given mass divided by gram molecular mass, 44. So, 4.4 by 44 is 0.1. So, 0.1 moles of carbon dioxide is containing 0.1 mole carbon and 0.2 mole oxygen. So, total it is 0.3 moles of atoms are present. What is he asking? But he is asking only oxygen atoms, and that too not in the form of moles, he is asking in the form of number of atoms only. So, this is a 0.2 into Avogadro number, 6 into 10 to the power of 23. So, this will become 6 to the 12 and 1.2 into 10 to the power of 23. This is the answer, 1.2 into 10 to the power of 23. Option D is perfect, right? So, going to the next question, the mass of a single atom in an element is 3.15 into 10 to the power of minus 23 grams. What is its atomic mass? One atom mass is 3.15 into 10 to the power of minus 23 grams. Then what will be the atomic mass? What will be the atomic mass? Mass of one molecule is, one atom, mass of one atom is 3.15 into 10 to the power of minus 23 grams. Then atomic mass will be 3.15 into 10 to the power of minus 23 into this one, 1.66 into 10 to the power of 10 to the power of, we have taken this one, minus 24. Okay. So, this makes your answer 10 to the power of minus 23, 10 to the power of minus 24, 10 to the power of minus 1. So, if you calculate this one, 3.15 into 1.66 into 10 to the power of minus 1, that will give you what is the atomic mass. What is the atomic mass? 3.15 0.15 Okay. So I think if you do the calculation, we should get to the exact answer, or else if you want it to be solved again, let us see it. Mass of one single atom of element M is 3.15. Sorry. Mass of a single atom of an element is 3.15 into 10 to the power of minus 23 grams, right? What is its atomic mass? Atomic mass, right? One atom mass is 3.15 into 10 to the power of minus 23 grams, right? Na? If this is the 3.15 into 10 to the power of minus 23 grams. Mass of 1 mole of atoms will be. Mass of 1 mole of atoms will be 3.15 into 10 to the power of minus 23. One atom is this many grams, then 1 mole of atoms will be into Avogadro number. 6 into 10 to the power of 23. 6 into 10 to the power of 23, right? So 23 minus 23 cancelling. So 3.15 into 6, that is 18.45, right? 18.45 grams is the 18.45 grams is the GAM. Understand this point. This is a mass of 1 mole atoms is 18.45 grams. Then what is AM? AM is the one which is denoted in unified mass or Dalton or AMU. Na? So 18.45 AMU is the atomic mass of that element. 18.45, or if you take 6.022, maybe the exact matching also will be there. You do the perfect calculation, you may be getting the answer to around 14th question as A, right? Na? So hope you have understood this one. First, what I am doing, from one atom mass, I am calculating mass of 1 mole atoms. There I am getting gram atomic mass. From that I am dropping G and I am putting AMU. That makes AM, atomic mass. Then what is RAM? RAM is dropping that also, that you will be getting it as 18.45 times. There will be no unit, right, in a relative atomic mass. But for us the question is atomic mass only. So this is what we have to give opt for, right? So that is 18.97 to very nearer. An atom of neon has a mass of, this is the same thing he is asking, similar to previous question. One atom is weighing these many grams. How many atoms of neon are there in 20 grams? So 20 grams divided by, it is same like if one chocolate is 10 rupees, how many chocolates will come for 100 rupees? Then what do? Total amount you are having, total money you are having divided by price of each unit you will take. So same is the thing we have to take here. Total mass is 20 grams. Within this 20 grams, how many neon atoms will be there, he is asking. So total mass divided by mass of one atom you have to take, so that you will be getting number of atoms. Number of neon atoms is equal to 20 grams divided by, what is the mass of one atom? 3.35 into 10 to the power of minus 23 gram. Gram get cancelled because it is just a number and there will be no units. So 20 by 3.33 into 10 to the power of 23. 20 by 3.33 means how much you will be getting? 6, 18, again 20. Yes, it is like 6.66 into 10 to the power of 23. Just to see whether any matching option is there. Just you do this calculation, perfect calculation. If I think 6, you have to get it. Okay. So if you do this calculation, you will come to know 20 by 3.633. You will be getting to what I can understand, either this answer or this answer. You can see here how close the options are here. 5.97, 6.02. Both are 10 to the power of 23, 10 to the power of 23 is there. So here you have to do accurate calculation and then opt for whichever answer is matching, right? So how many grams of sodium will have the same number of atoms as 6 grams of magnesium has? There is 6 grams magnesium given. In this 6 grams magnesium, some magnesium atoms will be there, right? First of all, we have to find out what is that number of magnesium atoms are present. Then what he is saying, what will be the mass of same number of sodium atoms as of magnesium atoms. Suppose you got in 6 grams magnesium, X magnesium atoms are there. Then you have to take X sodium atoms and calculate what is the mass. Understanding, right? Very simple point. So, number of magnesium atoms is equal to mass by atomic mass. So that becomes mass by gram atomic mass. In fact, so that is 6 divided by what is the gram atomic mass of magnesium. That is also already given. You need not worry about that. But in questions final, they may or they may not give. Generally, at the starting of the test paper, in the final paper also, they will be giving. But every time to flip in the computer to the first page, or in a NEET exam, you have to flip the pages in an offline exam and go to the first page and then referring. That becomes little time wasting or confusion also. These are all very simple basic concepts that it is by default every chemist has to memorize, remember them, right? So 6 by 24, so that is a 0.25 moles are there, 0.25 moles are there into Avogadro number, magnesium atoms. So how many magnesium atoms are there? 0.25 Na magnesium atoms are present. 0.25 Na magnesium atoms are there. Now 0.25. Now what we can say, how many grams of sodium? He is asking, how many grams of sodium? So now mass of sodium is number of atoms into mass of each atom, right? Number of atoms into mass of each atom, or else you can do like this also, number of moles into gram atomic mass you can take. Suppose it is like 0.25 moles is there into gram atomic mass of sodium is 23. So how much you will be getting here? This will be around 0.25 means around 8 grams you have to get. Yes, na? So 1/4 of 23. 1/4 of 23, it is very nearer to 8. 7 point something, right? You can do in this manner also. Okay. Number of moles, this how I have calculated this one is number of moles into gram atomic mass. Okay, na? Next, the total number of protons, electrons and neutrons in 12 grams of C12-6 is C12-6. First of all, how many grams he has given? 12 grams he has given. So therefore there is no worry also. He has given of 1 mole, right? So 12 C6 is 1 mole. So this will be having how many protons, how many neutrons and how many electrons. As it is a neutral in charge, number of protons equal to number of electrons, and mass number minus atomic number will give number of neutrons also. So it will be all of 1 mole only. 1 mole neutrons plus 1 mole protons plus 1 mole electrons, right now. So altogether it is 3 moles. 3 moles are present. So total number of so 6 into 10 to the power of 23 into 3. Yes or no? This is Avogadro number, this is Avogadro number, this is also Avogadro number. So Avogadro number into 3. So that is 18 into 10 to the power of 23. Particles are present. That particles are electrons plus protons plus neutrons all together. So 18 into, but answer is not there here. Total number of protons 18 into 10 to the power of 23 should be there, right? So what is the answer given to you? Anyway, so just take this one. This is the answer, 18 into 10 to the power of 23. I hope in your sheet option A is given, but that option A is not matching. Key mistake also in this question, right? So 18 into 10 to the power of 23 is the correct answer. Correct answer. Okay, na? So going to the next question, number of gram atoms. Do you remember what is the gram atoms is? Gram atoms is number of moles of atoms, right? So simply he is asking number of moles only. Number of moles or number of gram atoms. Number of gram atoms is equal to mass by gram molecular or gram atomic mass, right now? Gram atomic mass. What is the mass? Mass is 72 grams divided by gram atomic mass of magnesium. Gram atomic mass of magnesium, atomic number is 12, atomic mass is 24. So how much it will be? 12 2s are 24, 12 5, 12 6, 1 3, right? 3 moles of magnesium are present. Next, weight in grams of 2 gram molecules is, gram molecule means mole. So how many moles are there? 2 gram molecule means 2 moles, right? 1 mole H2O weighs how many grams? 18 grams. Then 2 mole weighs how much? Very simple, 36 grams. Double, right? 36 grams. Last question, number of gram molecules in 63 grams nitric acid. Nitric acid, first of all, what is the gram molecular mass of nitric acid? Just see, HNO3, hydrogen 1, nitrogen 14, oxygen is 16, 16 3 is 48, 8, 9, 10, 11, 12, 13, 63. So 63 grams itself is given, means 1 mole is given. 63 grams of nitric acid is given, means 1 gram molecule is given. 1 gram molecule means 1 mole. So this completes DPP 15 discussion, and now let's go into the next concept, that is so that is oxidation number discussion, right? So let us discuss in yesterday's class. To some extent already we have discussed. Yesterday means a previous class, and then let us proceed for the next concept. This all, I think, oxidation numbers are assigned to elements according to the following arbitrary rules. The electron shared between two like atoms is divided equally between two atoms. That is, if there is an atom A and another atom A, these are similar atoms. So when you are calculating what is the number of electrons that atom is actually having, you will be making the symmetrical breaking, right? Because both atoms are of equal in electronegativity. First of all, have you remembered what we were discussing? We were discussing calculation of oxidation number. Oxidation number is the charge on that atom when all the bonds with the surrounding atoms are broken according to their electronegativities. More electronegative atom will take the electron pair, the bonded pair. Less electronegative atom will lose that bonded pair of electrons. So, according to electronegativities, we have to break the bonds either homolytically or heterolytically. And homolytic, heterolytic already I have told you. Homolytic bond breaking is when a bond is present like this. Homolytic means like this. And when a bond is present, A let us assume, and this is AB. Let us assume that element B is more electronegative than A. Electronegativity of B is greater than electronegativity of A. Then what will happen? The bond breaks heterolytically, that both electrons will be taken by more electronegative atom only. A less electronegative atom will be losing its electron. Therefore, more electronegative atom will develop extra, it has gained an electron. This was its own electron. During bond formation, B only has contributed this electron into sharing. And during bond breaking, whatever the extra electron B is taking from the A is losing the electron, that B is gaining the electron, that B will get one negative oxidation number and A will be getting opposite positive oxidation number, +1, -1. But here, whatever the A has contributed, left side, right side A has contributed the electron during bond formation, that it is taking back. Therefore, 0 oxidation number will be there on both the atoms. That is what the first point, the electron shared between two like atoms are divided equally between the two atoms. That is, if A is there, it is equally distributed and equally divided. Then B, double bond B is there. So, that also will be equally divided. And if C, triple bond C is there, that also will be equally divided. So, in this manner, when like atom, between the like atoms bonds are there, they are equally divided. The electrons shared between two unlike atoms are counted with the more electronegative atom. That is what this factor. The second point is this only. The one which is more electronegative will be taking the bonded electrons, right? So, I am assuming B is more electronegative than A, therefore, B will take the electrons. Now, third point is in ionic compounds, the oxidation number of an element is equal to its actual charge on the ion. Suppose, what is the example for this third point? You see, suppose I take MgCl2, or else let me write this. First example, NaCl. First example, NaCl. NaCl is sodium chloride table salt, right? When NaCl is split into ions, right, it will be splitting into Na plus Cl minus. And what this third rule is saying, that when ionic compound is split into its respective ions, whatever charge is there on the ion, that itself is its oxidation number, that atom's oxidation number. So, sodium's oxidation number is +1, Cl oxidation number is -1. That is what he is saying. Suppose if I take the example MgCl2. Now, if I split this compound into respective ions, it will make it as Mg2 plus and 2Cl minus, right? So, magnesium oxidation number will be +2 and chlorine oxidation number will be -1. There are two chloride ions. Each chloride ion will have -1 oxidation number. So, Mg +2 is there, Cl -1 is there, another Cl -1 is there. All together will become 0 in charge. Understanding? All 3 points, hope you have understood, right? So, going to the next point, how to assign oxidation number. How to assign oxidation number. Oxidation number of an element in the free or elemental state means in an uncombined state. Suppose hydrogen is there. Hydrogen is present as a H2 molecule only. Both are hydrogen atoms only. Na? The linking between the two hydrogen atoms is not like a new chemical reaction. The two atoms itself has combined and are existing in an entity H2 molecule, right? Or neon atoms are there. Oxygen will exist as O2, nitrogen will exist as N2, like this, right? Phosphorus will exist as P4. In one of the example we have discussed, sulfur will exist as S8 molecule. Whatever it is, they are all in elemental state, no combination of two different type of atoms, then it is elemental or free state. In the elemental or free state, for any allotrope of that element, suppose allotropes means, I think it is the same element to exist in different physical forms is called allotropic forms, allotropes, right? One of the best example is carbon only, carbon diamond, carbon graphite, fullerenes, this soot, carbon black, all these are allotropes. Like that, so many are there. Nanotubes are also there. They are also the allotropes of carbon only, right? Carbon atom only. In all of them, carbon atom is only there, but they exist in different types of physical forms, right? So now allotropes, any allotrope you take, it will be 0. In the free state or elemental state, it will be 0. Thus, in elements, free or uncombined state, each atom bears an oxidation number of 0 only. In uncombined state, any atom's oxidation number will be 0. That is the first point. So, all these examples you can understand here how that is 0. All these you can understand that how all of them are in the elemental state. Even you can see here graphite. So, spelling mistake actually here, this is graphite. Graphite, right? So, that also has 0 oxidation number. The next point is oxidation number of a monoatomic ion. This point you have to understand, not all the ions, monoatomic ion. Monoatomic ion means the ion should have only one atom, Na plus, single sodium atom, single aluminum atom, single oxygen atom will have whatever their charges are there, they are only the oxidation numbers. Like here it is +1, here it is a +3, here it is a -2. So, monoatomic ion's charge itself is their oxidation number, right? Then going to the next point, the oxidation number of hydrogen is +1. In all the cases, it is +1 except in one case, that when hydrogen is attached with, bonded with active metals like alkali metals, sodium, lithium, sodium, potassium, rubidium, cesium, etc. Right? In all other cases, it will be +1 only, because hydrogen's electronegativity in general, hydrogen's electronegativity will be lesser than many of the elements, right? So, what we can say here is in general it is a +1 oxidation number, but rarely only when it is with active metals like alkali metals or alkaline earth metals like calcium, also calcium hydride. So, where it is -1. So, you can see in general means H2O, then NaOH, then C6H12O6, any of the general molecules you take, +1 will be the oxidation number of hydrogen. But when it is with alkali metals or some of the alkaline earth metals like sodium hydride, cesium hydride, right, lithium hydride, calcium hydride, etc., then it will have -1 oxidation number. What is the reason to have -1 oxidation number here? Is because in these molecules, I will go to one blank page. See, suppose if you take a H2O, in H2O, oxygen is more electronegative. Electronegativity of oxygen is greater than hydrogen, right? If oxygen electronegativity is more than hydrogen, what it will be when you are breaking the bonds? Let us assume oxygen is 16th group element, so it will be having 6 valence electrons. Now, when I am breaking the bonds, it will be like, as oxygen is more electronegative than hydrogen, the bond will break heterolytically, that both the electrons will be going with more electronegative oxygen only. Now, hydrogen lost the electron, that it will be +1. This also will be +1. But oxygen, earlier number of electrons before bonding is 6 only, 6 valence electron. But after bonding, after molecule formation, net how many it is getting? 8 electrons. So this makes oxygen -2 in oxidation number, right? -2 in oxidation number. So basically, as oxygen is more electronegative than hydrogen, oxygen will have negative oxidation number. Hydrogen being less electronegative will have positive oxidation number. Positive oxidation number. That is the reason why hydrogen is getting +1 and oxygen is getting -2 oxidation numbers here. But the same concept, if it is taken with hydrides, like a calcium hydride I am taking. In calcium hydride, if you see the electronegativity, comparatively, calcium's electronegativity will be, comparatively, hydrogen's electronegativity will be greater than calcium. If a hydrogen electronegativity is greater than calcium, let us assume that the molecule is formed like this, right now? Then how the bonds will be broken? Can you guess how the bonds will be broken? Hydrogen is more electronegative. This bond will break like this and this bond will break like this. So if these two bonds are breaking like this, hydrogen only will gain both electron, not only its own electron, it also will gain the extra electron from calcium. Therefore, hydrogen -1. And here also hydrogen is gaining extra electron. For its own electron, neutral. But for gaining extra electron, -1 oxidation number will come. And calcium is losing 2 electrons, therefore it will come to +2. So it will be +2 and -1 are the oxidation numbers, right? Calcium will be of +2. Calcium will be of +2 and hydrogen will be of -1. -1 into 2 actually. So total it will be +2 plus -2. Altogether will become 0. So that is what we can understand here. Okay, na? So hope you have understood this point. Now let's get back into our slide. Then second point, oxidation number of oxygen in general is -2 only. In general it is -2 because oxygen is second most highest electronegative atom, that, and also from the electronic configuration you can understand that in the valence shell oxygen has 6 valence electrons, right? 6 valence electrons. So how many electrons it is deficient to reach the octet configuration? 2 more electrons. And as it is second most electronegative atom, just after fluorine only, oxygen will be generally gaining that 2 electrons during bond formation, as it is one of the most electronegative atoms. So when it is gaining that 2 electrons, it will be reaching octet configuration and will get an oxidation number of -2, right? Already 6 are there, 2 more it will gain from the bond formation from with a less electronegative atom. Most of the atoms will be less electronegative only in comparison to oxygen. The one and only atom which is more electronegative than oxygen is a fluorine, right? So only when oxygen is bonded with a fluorine, we have to bother with the other elements. Generally, it will be with less electronegative atoms only. But there are cases where when oxygen atom is bonded with another oxygen atom, different situations will arise. That we will discuss as a special case, right? But right now for this point, what you can understand is in general oxygen's oxidation number will be -2 because it will be forming oxide ion. Oxide ion means -2 only, right? -2 only. But except in cases of peroxides, superoxides and ozonides. Peroxides, superoxides and ozonides. Let me explain that example also. H2O they have given for oxide, and peroxide H2O2 they have given. So let me give my own examples also. Suppose you take sodium oxide. In sodium oxide, sodium ion Na plus and 2 Na plus ions are there, and 2 Na plus means 2 plus. So to make it neutral, what the oxygen should have the charge? -2. This is what oxide, right? So oxygen will have -2 oxidation number. Not only that, you take a magnesium oxide, Mg2 plus O2 minus. Calcium oxide you take, alumina you take, Al2O3, in which aluminum is +3 and oxygen will be -2. Then how the molecule is made neutral? Is each aluminum is +3, like the 2 aluminums are there. So total will be +6, +3 into 2, +6. Then each oxygen is -2 and 3 such oxygens are there. -2 into 3, minus 6. So plus 6 minus 6. So both together 0. That is what the overall charge of the species. Understanding? And another case is what? In peroxides. This is in oxides. Right now? So in peroxides, it will be like Na2O2, H2O2, CaO2, MgO2, like this different peroxides we can take. So sodium peroxide, if you see Na2O2, so here 2 Na plus ions are there and 1 O2 2 minus ion is there. 2 oxygen atoms are not individual here. The 2 oxygen atoms are still in a bonded state between them. So that is the species O2 2 minus. O2 2 minus, 2 Na plus and 1 peroxide ion is there. Peroxide ion is there. And what is this peroxide ion is? Oxygen with a negative charge this is peroxide ion. Understanding? Now see here. Each oxygen is having one negative charge. Now if I want to break this bond between 2 oxygen atoms, how should I break it? Symmetrically only, homolytically only, because it is a bond present between 2 like atoms. So if this is the electron of this oxygen and this is the electron of this oxygen, I break it here. Now how many electrons are there in each oxygen? 1, 2, 3, 4, 5, 6, 7. 7 electrons are here and this also has 7 electrons, right? 7 electron means before this species formation, how many will be there in oxygen? In general, oxygen electronic configuration, 1s2, 2s2, 2p4. So 6 electrons are there. But how many are coming here? 7. How many are coming here? 7, right? Properly I will write. 7 we are getting. So 6 were there before, 7 are there after formation. So 1 extra electron. That 1 extra electron is making it to have the -1 oxidation number. 1 only extra electron, -1. If 2 extra electrons, -2. If 3 extra electrons, -3. Right now? So therefore in peroxide, oxidation number of oxygen will be -1 only. -1 only. Like this, there are species superoxides. Superoxides are like O2 minus, like a potassium oxide is there. KO2 is a potassium superoxide. In this, both oxygens together it is a -1 charge, right? 2x is equal to -1. Then x will be -1/2. So here oxidation number of oxygen in superoxides is -12. And in ozonides, ozonide means O3 minus, 3x is equal to -1, x is equal to -1/3. Oxidation number of oxygen in ozonides is -1/3. So these are some of the special situations, peroxides, superoxides and ozonides, where oxidation number will be different. And one more exception is there, that is when oxygen is bonded with the one and only more electronegative atom, fluorine. When oxygen is bonded with fluorine, OF2, let us assume, OF2, right? Now, in this case, it is very clear that electronegativity of fluorine is greater than oxygen. So, in this case, what will happen? Fluorine will have negative oxidation number and oxygen will have positive oxidation number, yes or no? The one with higher electronegativity will have negative oxidation number and the one with lesser electronegativity will have positive oxidation number. So in that manner, if you see, fluorine is the highest, most electronegative atom, therefore this does not lose electrons to any of the atom, any of the element, because it itself is the highest electronegative atom. It can gain the electron from any of the element from the periodic table, but it will not lose electron for any of the element. This point, if we understand, what we can say the logic is fluorine's electronegativity is, fluorine's electronic configuration is 1s2, 2s2, 2p5, right? 2p5. So 7 valence electrons are present and it is the highest electronegative atom. So always will be showing the tendency to gain 1 electron. It will be gaining 1 electron only. There is no other situation. Gaining of 1 electron. That's it. So fluorine oxidation number will be always minus 1. Fluorine oxidation number in the combined state will be always minus 1. So if a fluorine is a minus 1, oxygen will be x plus minus 1 into 2 is equal to 0. Then x minus 2 is equal to 0. X is equal to plus 2. Here oxygen is having positive oxidation number. And I will give one more example also. You do it later on. O2F2. In O2F2, try to calculate oxidation number of oxygen, because fluorine's oxidation number is a fixed. Oxygen has the exceptions. Fluorine does not have exceptions. In all its combined state, in compound formation, it will have minus 1 oxidation number only. Minus 1 oxidation number only, right? So going to the next point. Coming to this earlier one, this exception and all already I have explained you, I have made you. Now going to, here is a fourth point, next fifth point. The oxidation number of fluorine is always a minus 1, that also already we have taken. But other halogens oxidation numbers can be positive also, like chlorine, bromine and iodine. When they are bonded with more electronegative atoms than themselves, then they will be having definitely positive oxidation numbers. So that point also we can consider, right? Then in oxyacids and oxoanions, the positive oxidation numbers will be there. Suppose if you want to know what are oxoacids, I say like oxoacid HClO4 perchloric acid. In this perchloric acid, chlorine is bonded with a more electronegative atom than itself, that is oxygen. So it will be plus 1 plus X plus minus 2 into 4 is equal to 0. Because oxygen is more electronegative, so definitely it will be having negative oxidation number only, right? So is equal to 0. So if this is there, 1 plus x minus 8 is equal to 0, x minus 7 is equal to 0, x is equal to plus 7. So in oxoacids, chlorine is having plus 7 oxidation number, particularly in this compound. Like oxoanions are there, IO3 minus, this is a iodate, right? So in iodate ion, iodine, I am assuming that its oxidation number is X. So X plus minus 2 into 3 is equal to minus 1. So X minus 6 is equal to minus 1. X is equal to, if minus 6 goes on that side, it will become plus 6 minus 1 plus 5. So here iodine is getting positive oxidation number, right? So it is the point only for fluorine always will have negative oxidation number, that too minus 1. But for remaining halogens, chlorine, bromine, iodine, general oxidation number is a minus 1 only, but they can also have positive oxidation number when they are bonded with more electronegative atoms like oxygen and fluorine than themselves. Like next, I think 7th point is also pending. No, 6th is also pending. In compounds formed by the union of metals and non-metals, metals will have positive oxidation number. This point already we have seen. Suppose you take a sodium chloride, metal will have positive oxidation number and non-metal will have negative oxidation number. Positive oxidation number Na plus it is, so plus 1, and this is Cl minus, though it is a minus 1 oxidation number, right? The next one, in compounds formed by the union of two non-metals, the one which is more electronegative will get the negative oxidation number. Suppose if I take a methane molecule CH4, in a methane molecule carbon is more electronegative than hydrogen. Therefore, all whatever the electrons of hydrogens are there, they will be considered, they will be taken by carbon only, right? So like this, carbon is non-metal, hydrogen is also non-metal. So in this case, what is happening here? Carbon is gaining 4 electrons from 4 hydrogen atoms. So carbon is a 4 minus, and each hydrogen is plus 1, because the hydrogen is losing the electron, carbon is gaining the electron. Similar example, if you take CCl4, in CCl4 carbon is less electronegative, chlorine is more electronegative. So in this case, suppose if I take the molecule like this, right, these are the electrons of carbon and these are the electrons of chlorines, right? So when these bonds are broken, how they will be broken is like this. So carbon is losing all the 4 electrons, so carbon will become 4 plus, and each chlorine is gaining a 1 electron, each chlorine gaining 1 extra electron from carbon. So each chlorine will be of -1 oxidation number. So in this example, methane, carbon is negatively oxidized, carbon is having negative oxidation number, whereas the same carbon in CCl4 is having positive oxidation number. So we have to understand this point, oxidation number is just dependent on with which other element this element or this atom is in a bonding. Is it in a bonding with a same electronegative atom, that oxidation number will be 0, or is it bonded with a more electronegative atom than itself, that it will have positive oxidation number, or is it bonded with a less electronegative atom than itself, that it will have negative oxidation number. So accordingly, oxidation numbers will be defined, will be calculated, right? So we will stop it here, and some more points are there and we will be discussing tomorrow. And one more important thing I have to tell you, that tomorrow is our last lecture for CBC 2 program, right? So we will try to complete oxidation numbers, but we will be left over with one chapter, that is a BIN. If you have the material, you can go through that. There is a basic inorganic nomenclature, but time is not there for that one. Therefore, I will record the BIN topic and will upload in our YouTube channel, official YouTube channel, Resonance Hyderabad. That in that you can go through it and then can understand the concept, and when you come back, you can ask the doubts, or even I have already shared you my contact number, so you can WhatsApp me your doubts, that I will send you the solutions, right? So hope you have understood today's topic and enjoyed also. So we'll meet tomorrow with further discussion of this chapter. Thank you. All the best.
थोड़ा नीचे ना. Good morning to all of you. Let us continue with the problems. Draw free body diagram of the block in the given figure placed on a floor. Simple. You have a body. Now, identify how many forces are acting on this body. No external agency is exerting any force. Only weight is acting downward. If you take mass m, then W will be equal to mg. And one contact force will act. That contact force is acting here, and you can show it in this direction, and this is your normal reaction. Body is at rest, so normal reaction will be equal to m into z. For equilibrium state only, n will be equal to mg. If n will be greater, body will move upward. Mg will be greater, body will move downward. Let us move to next question. Draw free body diagram of the block of mass m hanging with the help of a string as shown in given figure. You have a string, and from this string a block of mass m is being kept. Now they are asking you draw free body diagram of the block. Now this is the block. On this block downward you are taking mg. You know that tension acting on the block will be in opposite direction of applied force. So mg is acting downward. On the block, tension in the string will act upward, and since it is at rest, T will be equal to m into g. Let us move now to next question. Draw free body diagram of the two blocks shown in the figure. Now, if you take here 2m, here F is acting, and in between this 2m and m, a contact force will act. This contact force you consider as Fc. So this is contact force, and if I take m here, so here this is contact force, and here F is acting, because external forces acting on both the blocks are equal. So body will not move, body would be at rest. So see the free body diagram for 2m and free body diagram for m. Is it clear to you? Now, let us move to next question. Draw free body diagram of the blocks A and B in the given figure. There are two blocks A and B. If I take block A, downward, its mass they have given you MA 1 kilogram. So here MAG will be acting, 1 into G Newton will be acting, and in this string tension will act. Let us take it is T1, and because A is at rest, so T1 will be 1 G. If you are taking G as 10, then T1 will become 10 Newton. Now go for 3 kg. This is 3 kg mass. Here just concentrate only on one body at one time, and then identify all the forces which are acting on that body. Now 3 kg, here tension T2 is acting, and here tension T1 is acting, right? System is at rest, so T2 must be checked here. If you take T2 here, it will be total because T1 is 1 G. So its mass will be acting downward. If I will take T2, T2 will directly become 4G, 3G plus 1G, that will become your 4G. Weight undoubtedly of 3 kg you will be taking downward. Clear to you? Now, undoubtedly weight if you want to show here, you can show 3G. Okay, no? So total T2 will become 4G, T1 will become 1G. Let us move to next question. Draw free body diagram of a 1 kilogram block placed on a rough inclined plane. If your plane is smooth, you will not have to consider frictional force. But if plane is rough, you will have to consider also frictional force. So if I am taking this inclined plane, they have given you angle theta. Let us suppose this theta. Theta they have given you 37 degree, right? And here it is 1 kg. So let us take M. This is M. This is 1 kg. So mg will act downward. Clear to you? Now this angle is theta. This will become 90 minus theta. If you take like this, then this is angle theta. You will be taking here, right now. This is 90 minus theta. This angle is theta. So this will become mg cos theta. Here mg sin theta. And here there will be normal reaction of the surface, of this inclined surface. So what will be the value of n? N will be equal to mj cos theta, because body has tendency to slide downward. So in this direction, here one more contact force will act, and this is force due to friction. Force due to friction will be equal to mu into n, mu mg cos theta. In limiting case, if body is not sliding, just it is on the verge of sliding, in that case you can say that mg sin theta will be equal to mu mg cos theta, that is mu will be tan theta. Then theta will be called limiting angle of friction. Clear to you? And if suppose mg sin theta is greater than force due to friction, that is mu mg cos theta, then body will be sliding down with constant acceleration. If force due to friction limiting value will exceed mg sin theta, then frictional force will be static friction, body will not slide at all. Clear to you? But here simply they say you to draw free body diagram, you will have to identify all the forces which are acting on the body. Actually, only you are considering two forces, mg vertically downward and force due to friction will be acting along the inclined plane in upward direction, opposite to the direction of tendency of motion. Motion may be, motion may not be. Let us move now to next question. A body of weight W1 is suspended from the ceiling of a room through a chain of chains of weight W2. The ceiling pulls the chain by a force. So you have the ceiling from here with the help of chain, a body is hanging. Body has weight W1. So this W1 is acting downward. If it will have mass m, W1 will be equal to m into g. And they have given you the weight of chain. Its weight is also they have given you, this is W2. The ceiling pulls the chain. So if you take this body, free body diagram, so here W1 is acting, right? And here there will be tension. But here if you take, at this point, W2 is acting plus W1 is also acting. So they are asking you, the ceiling will pull the chain by force of, it is in equilibrium. So whatever upward force is acting here, that the same force will be acting in downward direction. The total weight which is acting on the body in downward direction is W1 plus W2. So what will happen? The ceiling will pull the chain by force of F. If I show it as F, F will be equal to W1 plus W2. Your answer will be C. Check. It is clear to you. Simple. It all depends upon free body diagram, and you will have to take, first identify what are the forces which are acting on the body and take resultant of all the forces. Next, let us move to question number 7 now. A block of mass 0.2 kg is suspended from the ceiling by a light string. Whenever they say you light string, it means mass of the string is completely neglected in comparison to mass of the block. Clear? Now, in that case, tension at every point of the string will be equal. A second block of mass 0.3 kg is suspended from the first block through another string. Find the tension in the two. So first I am taking the ceiling and then I have taken a string whose mass is neglected, and now from this I have suspended a mass, let us take M1 0.2 kg, okay, no, and then they say you a second block of mass 0.3 kg. Now this is second block, let us take M2, its mass is 0.3 kilogram, suspended from the first block. Find the tensions in the two string. Here is tension T1, here you take tension T2. Now, if you consider tension T1, so T1 will be equal to M2G 0.3 into 10. It will become 3 Newton. Now, if you go for T2, the T2 will be equal to here M1G plus T1. This is M1J plus T1. This is nothing but M1 plus M2 into J. It is 0.2 plus 0.3 into 10. This will become equal to 5 Newton. So tension in lower string is 3 Newton and tension in the upper string is 5 Newton. Your answers will be 3 Newton and 5 Newton. Slowly try to understand each and every step, basic problems related to free body diagram and tension. All these problems are basic problems. Okay, let us move to next question now. Two blocks of equal mass M are placed on a smooth horizontal floor. I have a smooth horizontal floor means you should not consider friction. A smooth horizontal floor, the moment you say smooth means friction is completely neglected. Now two blocks of equal masses are placed and tied to each other through a light string. So two blocks of equal mass. So this is M. I have taken a light string, means tension at every point will be equal, and this is second M. One of the block is pulled along the line joining them with a constant force F. So here you have applied a constant force F. Find the tension in the string joining the blocks. I told you, consider first whole as one system. Means M1 plus M2 you are considering as one system. If you consider them as one system, then you will have, suppose system goes with acceleration A along the direction of line of action of force. No friction is there. Whatever force you will apply, body will move, whatever may be the mass. It is not like that. If a very heavy mass is there, it will not move. It will guaranteed move because there is no force which will oppose the motion of the body. If friction would be there, then you can consider. But here, surface is smooth. So whatever force you will apply, both masses will be accelerated. So here, only one force is acting on the whole system. So F will be equal to M plus M. This is M plus M into A. This gives you A equal to F by 2M. You are getting acceleration equal to F by 2M. Now I am taking tension T here, T here. They are asking you find the tension in the string. The easiest technique is consider now free body diagram for M only, this M. So on this M, only tension is acting and this M is going with acceleration A. So your T will be equal to M into A. M. A is F by 2M. From here, M is cancelled. T will become equal to F by 2. Your answer will be F by 2. Check the complete solution. First, for drawing free body diagram, I have taken both blocks as one system, and then I had considered free body diagram of the left mass. Even you will take free body diagram for that mass, answer will be same. How? I would show you. If I will take this, then here F will act, here T will act, this is M, system goes in this direction. So F minus T will become equal to M into A. you want T. T will become F minus MA. This will become F minus M. A is F by 2M. MM cancelled. F minus F by 2 will become equal to F by 2. T will become equal to F by 2. Compare this with this, you are getting same answer. But it is taking more time, calculation will take few seconds more. Now, let us move to next problem. You have two blocks A and B of masses MA and MB, it should be, respectively, are kept in contact on a frictionless table. Pre-assumed the surface of table is horizontal. You have two blocks A and B. So this is A and this is B. This is A, this is B. Its mass MA, its mass MB. Frictionless table, so we will not consider at all the friction. The experimenter pushes the block A. So, some person is pushing the block A. Let us suppose he is pushing with force F dash, so that the block accelerates. So, whole one system you take, the system will be moving with acceleration A. So, what you do, your F dash will become equal to MA plus MB into A will become equal to F dash by MA plus MB. In hand, acceleration you have kept, okay, no? Further you see what they say. If the block A exerts a force F, in between these two, contact force is acting, that is F. So, what you do, whatever force A will exert on B, the same force B will exert on A. So, F will become how much? F will be equal to, you see block B. This is block B. Here F force is acting and this is moving with acceleration A. So, F will become MB into A MB, or F equal to MB F dash MA plus MB. This is the value of F. They are asking you what is the force exerted by the experimenter on A. Means they are asking you the value of F dash. So, this is giving you F dash equal to MA plus MB into F by MB. This is the force exerted. You just see that this is the force exerted by experimenter on A. F dash. F is the contact force in between A and B. Both are equal in magnitude, opposite in direction. Your answer is MA plus MB into F by MB. Let us now move to next question. Okay, now you have a small block B placed on another block A of mass 5 kg and length 20 centimeter. Okay, you are considering, I'm drawing again, this is block A of mass 5 kg, MA 5 kg, its length is 0.2 meter, 20 centimeter they have told you, it means that this length is 0.2 meter. And there is block B which is near to the right end. Here is block B. You will consider it just a point mass, a constant horizontal force. A constant horizontal force you have exerted here. This F is 10 Newton, right? All the surfaces are assumed frictionless, means no need to consider friction. Find the time which will be elapsed before the block B separates from A. The first, you see, if I take free body diagram for A, what will happen? If this is A, here mass is 5 kilogram and you are applying force of 10 Newton. Right now, this is body A. Body B is situated on it, but because friction is not there, so it cannot oppose the motion of body A. So 10 Newton force will be acting only on body A of mass 5 kilogram. So acceleration of body A 10 F will be equal to ma into A. So it will move in this direction with acceleration A 5 into A. So you are getting A equal to 2 meter per second square. So your acceleration is 2 meter per second square. Once you got acceleration, this distance they have given you 0.2 meter. If you consider relative motion, you can assume now that body B is moving. If it is moving from left towards right, the body B will be moving from right towards left with same acceleration A. Now, use formula L equal to half A T square, because initially body B is at rest. So initial velocity is 0. So ut plus half at squared, your ut is 0. Now you want t. So t will be equal to under root 2L by A. Under root 2. L is 0.2 by A is 2. 2 cancel. So your t will be equal to under root 0.2 means 2 by 10, means under root 1 by 5 second, or simply you can say root of 0.2 second, or under root 1 by 5 second, or 1 by root 5 second. That will be the answer. Check it properly. Okay, now, here interesting fact is, even though this body is kept here, if friction would be there, then if you apply 10 Newton, then here there will be an opposing force acting on the body. But because friction is not there, so there will be no opposing force at all acting on the body. So whatever 10 Newton you have exerted, this 10 Newton is acting on 5 kg only. So acceleration of body A you have taken as 2 meter per second square. And then you have considered relative motion. A is moving from left to right. You will assume that if any observer is sitting on B, right, he will see A. Then for him A is moving towards right. So if there is an observer sitting on A, will feel that body B is moving from right towards left. Clear to you? I hope you understood this. If you understood this, then now next problem, two blocks are kept in contact with each other on a smooth surface. So I have two blocks. Let us draw first the figure. This is 6 kg and other one is 2 kg perhaps. This is 2 kg. It is not that much clear. It's 2 kg or 4 kg. Okay. I can take 4 kg also you can take. Let us take it is 4 kg. You are applying 10 Newton. Now what they ask you? These two blocks are kept in contact with each other. Any mass you take, technique will remain same. Two blocks are kept in contact with each other on a smooth surface. Again, friction you are not considering. The force on the lighter block. So they are asking you how much force is acting here. Means contact force they are asking you. First, what you consider whole as one system. If you consider whole as one system, total mass will become 6 plus 4, 10 kg. On 10 kg, 10 Newton force is acting. So, this 10 Newton will become 6 plus 4 into A will become 1 meter per second square. So, this is acceleration of both the blocks moving in this direction. Now, consider free body diagram only for 4 kilogram. So, here I am considering only 4 kilogram and here this is force of contact and this 4 kg is moving from left towards right with an acceleration A. So, your force of contact, this will become 4 into A. 4. A is 1 Newton. You will get 4 Newton. It means that the force which is acting on 4 kg, which is lighter than 6 kg, will be only 4 Newton. So, answer for this question will be B. Check your understanding or not. Very simple. First, 6 kg and 4 kg you have considered as one system. Whatever force 10 Newton is acting, you have considered it to be acting on 10 kilogram and then from that you got acceleration. Then you have taken free body diagram for 4 kg. Same answer will come if you take free body diagram for 6 kg. But in that case, let me show you, you will get more information. If this is 6 kg and here it is 10 Newton and here it is force of contact, this is going in this direction with acceleration A, then you will have 10 minus Fc equal to 6 into A. A is 1 is 6. So 10 minus Fc is 6. Fc will become 10 minus 6. Again you check 4 Newton. Both answer, are you getting same? Yeah. So you take force acting on 4 Newton or the force exerted by 4 Newton on 4 kg on 6 kg, both answers are same. Now, let us move to next question. Now, all the questions, whatever were there, we have fully completed from Newton's laws. Okay, no, in this so many things are there. When you will be coming near us, we will be teaching you for basic concepts only this much. Along with this, some more extra points I will say you. Then according to our schedule, our next unit will be work power energy. I will be giving you basic fundamental concept related to that. But before that, some more concept related to tension, pulley and free body diagram I want to say to you. First, a bit recap. Suppose I am giving you 5 bodies. This is first body 10 kilogram connected with a string 20 kilogram, again connected with a string 30 kilogram, then connected with a string 40 kilogram, then connected with a string 50 kilogram, and you are exerting force F here. Okay, let us suppose here tension is T1, here tension is T2, here tension is T3, here tension is T4, and they are asking you to find the values of T1, T2, T3 and T4. What you will do? First, as I have told you, the first one, consider whole system as one. Means 10 kg, 20 kg, 30 kg, 40 kg, 50 kg, all you take as one system. Surface is smooth, so no frictional force will be acting. Then your F will become equal to how much? F will be 10 plus 20 plus 30 plus 40 plus 50 into A. Let us take some value of F. Let us suppose F is 300 Newton. So, your 300 will become 30, 60, 40, 100, 150 A. So, your A will become 2 meter per second square. Now, you want to find out T1. Just concentrate on body of 10 kilogram. Friction neglected, you have not considered, surface is smooth. So, on 10 kilogram, only one force is acting, that's T1. So, your T1 will be equal to 10 into A, 10 into 2, this will become 20 Newton. Clear to you? Next, you will be considering now T2. For T2, 20 kg and 10 kg, these two consider as one system. Then if you consider this as one system, then again only one force will act. T1 will become internal force acting in between T1 and T2, right? Then your T2 will be equal to 10 plus 20 into A, 30 into 2, this will become 60 Newton. Clear to you? Now, take T3, here T3. For T3, 30 kg, 20 kg, 10 kg, all three together consider one system. Then T1 and T2 will become internal forces, you will not have to consider. Then what will happen for T3? T3 will become 10 plus 20 plus 30 into A. This will become 60 into 2. It will become 120 Newton. Now you take T4. For T4, 10 plus 20 plus 30 plus 40, this whole you consider as one system. If you consider that as one system, then this will become 10 plus 20 plus 30 plus 40 into A. Okay, 100 into A, this will become 100 into 2. This will become 200 Newton. check. You have obtained T1, T2, T3 and T4. Now, let us move some more problems I am doing from my own side. Each and every problem of your classwork, homework from CBC book, we have already completed right now. Now, second problem, I am giving you here a body of mass, some mass you take 2 kg, and here there is a pulley, and here you have suspended some mass you take. I am taking as 3 kg. Okay, we want to find out tension and acceleration, okay, of the system of tension. For that, you take free body diagram for 3 kg and 2 kg separately. For 3 kg, this is 3 kg. So here 3G is acting, here T, here T. So here T will be acting right now. So what will happen? 3G minus T will be equal to 3 into A. System is moving in this direction with acceleration A. Okay. Now consider now 2 kg. For 2 kg, surface is smooth, so only T is acting. System is moving with acceleration A. So T will become equal to 2 into A. Add these two equations. T and T will be cancelled. You will be getting 3G equal to 5A, A, 3. G take 10 meter per second square by 5. It will become 6 meter per second square. You may also obtain A by considering A equal to F net by M total. 1 second. Two more pages you had. So A will be equal to F net by M total. Now F net, you see here, this 2 kg will not exert any force. It is on horizontal surface, friction is not there. So what we are going to do, F net is only this 3G, F net is only 1 minute, okay. You are considering now F net as 3G, M total 3 plus 2, 3 into 10 by 5. You are again getting 6 meter per second squared. Okay, now check. This is also one method. You will just consider F net by total mass. Or better technique is you take free body diagram for 3 kg and 2 kg separately. If you take these two separately, then also it is possible. Once you got A, substitute anywhere. I am substituting in this equation. T equal to 2A. So 2 into 6, you got T equal to 12 Newton. So your acceleration is ready, 6 meter per second square. From upper equation also you will get same value of T. How? 3G means 30 minus T, 3 into A is 6. So T will be equal to 30 minus 18. Check. You are getting 12 Newton. Check this two. You will be getting same answer. Either you take free body diagram for 2 kilogram or you take free body diagram from 3 kilogram. Clear to you? Next, Actually, Atwood machine they have not introduced, okay, but because so much you have learned, so basic of Atwood machine you can learn here only. Suppose name is Atwood machine, nothing is there. There will be a single pulley from which two body will be hanged. Okay, no. So here, see what is Atwood machine. ATWOOD, Atwood's machine. So from here, I will have a pulley from which will suspend two masses, M1 and M2. A string is passing over the pulley like this. Let us suppose M2 is greater than M1. If M2 will be greater than M1, then M1 will move up, M2 will move down. Since you have neglected mass of this string in comparison to masses of blocks M1 and M2, so what will happen now? Okay, now tension at every point on the string will remain equal. Remember, tension will be equal under two conditions. Mass of the pulley completely neglected, so no need to consider moment of inertia and all. And secondly, mass of a string also you are neglecting in comparison to masses of the block. You cannot say that they are massless. In many problems they say massless string, massless pulley. If there is massless, body will not exist. Every physical system will have some mass. So better way to say that mass of a string or mass of pulley you are neglecting in comparison to M1 and M2. Now take free body diagram. If I will take free body diagram for M2, then M2G will act downward. Here tension is acting. Here tension is acting. Now take resultant. M2G minus T, this will be M2 into A. Clear to you? This is M2G minus T equal to M2A, equation 1. And now go for M1. For M1, this system is coming down. Now you are taking M1. Here T is acting up, M1G act downward, and system is going up with acceleration A. Then you take the equation T minus M1G M1 into A, equation 2. If you add this equation and this equation, your T will be cancelled. What will be left? M2 minus M1G will be equal to M1 plus M2 into A. So your A will be equal to M2 minus M1G by M1 plus M2. You got the value of acceleration by taking free body diagram for A and B. Without considering free body diagram also you may be obtaining the value of acceleration. How you will be getting that? For that, what you do, you will be taking A equal to F net by M total. Now you see M2G is acting downward, but M1 is hanging other side. Because M1 is hanging other side, so what M1G will do? It will oppose M2G. So net force acting on the system and mass of the pulley you have neglected, whether that will also come into picture. But now what will happen? Net force will become, M2 is heavier. So it will become F net equal to M2G minus M1G. So F net will be equal to M2G minus M1G by M total. M total is M1 plus M2. Mass of the string neglected, mass of the pulley neglected. So total mass will be simply M1 plus M2. So this is acceleration of the system. With this acceleration, M1 is moving upward and M2 is moving downward. Now you want to find out tension. From any one equation, either using 1 or using 2, you can get tension. Let us use equation 2, it will be more easier. So your T will become, from equation 2, M1G will go that side. T will be equal to M1G plus M1A. Now, M1G plus M1. A is M2G minus M1G by M1 plus M2. So what you are getting? This is equal to M1 plus M2. This will become M1 square J plus M1 M2G plus M1 M2G minus M1 square G. M1 square G, M1 square G cancel. T equal to 2 times of M1 M2G by M1 plus M2. Check, this is your tension. T will be 2 M1 M2G by M1 plus M2. If I go to previous problem, okay, no, this problem, you can check the tension. This is M1 M2, right now. If T will talk, it will become half of that. M1 M2G by M1 plus M2, you can check. T M1 M2, 2 into 3 into 10. M1 M2G by M1 plus M2. Check here, 2 plus 3. It is 5, 2 times. Are you getting 12 Newton? Check. Anyone you can take M1, M2. This is M1. And this one you take M2. Shortcut way to remember. In acute machine, tension is 2 times M1 M2G by M1 plus M2. And in this case, it will become, okay, no, M1 M2G by M1 plus M2. A easy technique to solve the problem, objective based, suppose exam is there, you will be getting answer in a very short duration of time. So I hope you people have understood. Further, I will be talking about this free body diagram, tension problem related to string, multiple pulley system also. I have shown you just a single pulley in acute machine. Okay, no? I can consider multiple pulley. Here pulley is fixed. We'll be considering variable pulley. We'll consider mass of the pulley. All in more depth we'll be learning when we'll be coming near to us. Now, as CBC syllabus is concerned, our next unit is basic concepts related to work, power and energy, mainly work done. So, let us start now a new chapter, and in that, this is new chapter, work, power, energy. This is a new chapter, some basics of work done will be learning now. Okay? So let us consider what is work done. Suppose I have a body. This is a body, mass M. I am exerting the surface for time being. You take it is smooth because we have not learned friction. So we will be considering for all these problems in CBC course as a smooth surface only. Now you are exerting a force F here, and here displacement is there. Angle between force factor and displacement factor is theta. What is work done? If on any body you are applying a force F and there is no displacement, like this wall is there, on this wall I apply the force. Will the wall move? No. Okay, no. When wall is not moving, even though you are applying force, there will be no work done. Your work done will be 0. What is work done? If there is a component of force along the direction of displacement or opposite to the direction of displacement, a component of force, then we say that there will be work done. Simple definition. Means for work to be done, there must be two quantity. One, force acting on a body. Undoubtedly in the beginning there must be a body on which you will be doing work, or body itself will do work if it is situated in a field. So suppose I have a body of certain mass. If there is a body, there will be some mass. You have applied force F and body is displaced. Suppose body is displaced at an angle theta, means angle between displacement factor and force factor is theta. What will happen? There will be a component of force along the direction of displacement. Right? You will say that work is being done. Mathematically, we say that W, first thing that all these three quantities, work, power and energy, are a scalar quantity. Right? When we will be coming, I will be teaching you in vector unit. I told you in the beginning we will not teach you physics. We will be teaching you mathematical tools, and a bit in depth we will teach whatever math we need for learning physics. We will be teaching you. For example, vector we will teach you, differential calculus we will teach you, integral calculus we will teach you, basic algebra, trigonometry, coordinate geometry, all we will teach, and then only we will start physics. So here, mathematically, if you want to define work done, then it is taken as dot product of force and displacement. When you multiply, see beta, in class 10, whenever you have multiplied, you have taken any symbol, dot symbol, cross symbol, or you have not taken any symbol, A, B, A dot B, A cross B, all have the same meaning. But now in physics, all three have three different meaning. If I take dot product, means I am putting dot in between force and displacement, then it is a type of product in which resultant will be a scalar quantity. Work done is a scalar quantity. You will be stunned to know, same I will take displacement and force and I will take cross product, your quantity will not be work done. Now it will be a vector quantity and it will become torque, right? At this time, why to speak about dot product and cross product. Simple definition of work done we are taking. Work done is dot product of force and displacement. When we take dot product of two vectors A and B, suppose this is vector A, this is vector B at an angle theta, then resultant will be equal to A dot B, you are taking dot product, then R dot product you have taken, so this will be a scalar quantity. When this is a scalar quantity, it will become mod A mod B cos theta. B cos theta is component of A along the direct check. B cos theta is component of B along the direction of A. You can take also component of A along B. Component of A along B will become A cos theta. So either you take product of B cos theta to A, or you take product of A cos theta to B, answer will be same. Is it clear to you? So simple at this time you take work done will be equal to mod F mod S cos theta. F magnitude of force, S magnitude of displacement, theta angle between force and displacement. So work done is Fs cos theta. Based on this is work done by a constant force. So now if you take this one is M and I take 4 quadrant, I am taking displacement here. If and here you have taken F. Now you have cos theta. This is first quadrant, second quadrant, third quadrant, fourth quadrant. Remember, if there will be a component of force along the direction of displacement, work done is considered to be positive. Means you can classify work done in 3 categories: positive work done, zero work done, negative work done. If there will be a component of force along the direction of displacement, then work done is considered to be positive. How? When it is possible? It is possible when F, when this theta value will be in between 0 degree and 90 degree, not 90 degree. It should be less than 90 degree. Means 0 is in between 0 and 90. 0 included but 90 is not included. Or theta will be, means force should be in the 4th quadrant. I have taken S along x-axis. 4th quadrant means the value of theta should be in between 270 degree and 360 degree, not considering 270 degree. Okay, no? So theta should be in between 270 and 360 degree, 270 not considered. Okay, no? Then there would be a component of force, means theta should be in between 0 degree and 90 degree, but you are not considering 90 degree. Or theta should be in between 270 degree and 360 degree, you are not considering 270 degree. Because 90 degree and 270 degree, in that case, it will be at, force will be at right angle to displacement. If it will be at right angle to displacement, what will happen? Okay, cos 90 you know 0, cos 270 you know 0, your work done will become 0. Clear to you? The simple definition, work done is considered to be positive if there will be a component of force along the direction of displacement, means force should be considered in first or fourth quadrant. Next, when work done will be 0? When F will be acting at 90 degree to displacement, means theta should be 90 degree or theta should be 270 degree. If theta will have any one of these two values, then work done is considered to be 0. For example, if a particle is moving in a circular path, centripetal force will always act at right angle to its motion. So theta will be 90 degree. In uniform circular motion, work done by centripetal force will always be equal to 0. It is happening when a charged particle is entering at right angle to any magnetic field. Whenever it will enter into a magnetic field, the F equal to Q V cross B. F will always be at right angle to V. So work done by magnetic field on moving charged particle is 0. So kinetic energy of charged particle will never be changed. Okay, no. There will be no work done. So work done will be 0 if theta is 90 or 270, or you can say that when force is acting at right angle to its motion. Did you understand that? If now, last case you take, if second quadrant or fourth quadrant not considering 90 and 270. So if theta is greater than 90 degree and less than 270 degree, I have not put equal to beta. Theta should be in between 90 degree and 270 degree, means if it is in second quadrant and third quadrant, then there will be a component of force in opposite direction to that of displacement. When either directly you say, when force and displacement factor will act opposite to each other, theta 180 degree, a special case, guaranteed work done is negative. If you consider that there is a component of force in a direction opposite to the direction of displacement, then we consider work done to be negative. All these I am speaking about a constant force. If there will be a variable force, then there will be only two techniques to calculate work done. One, easiest one, that plot a graph by taking displacement on x-axis, force on y-axis, area of force displacement graph will give you work done. Or you will have to use concept of integration. That one I will speak tomorrow. So just basics of what is work done. That one also work done by constant force. You remember formula W equal to Fs cos theta. F is the force acting on the body, S displacement of the body, theta angle between force and displacement factor. Okay, further about work done I will tell you tomorrow, and some basic problems also related to work done we will be doing tomorrow. Okay, time is over. Thank you for today. Okay, no? Yeah, 10 minutes break you will have, then your math class will start. Clear to you? Okay, have a nice day. Thank you again.
Good morning, students. So last time we have discussed sets, and today we are, I think, the second last lecture. So we will be discussing the questions on set, and there is a further operations on set. So we'll be doing that today. All right. So let's discuss first the homework which I have given the last time. All right. Okay. What is the first question? Which of the following is not correct? Right? Which of the following is not correct? A is a subset of A complement if and only if A is equal to 5. Right? If A is equal to 5, then A is a subset of A complement. Okay. A complement is a subset of A if and only if A is equal to X. X is the universal set. Alright. A union B is equal to A union C, then B is equal to C. Right? Then B is equal to C. And A is equal to B is equivalent to A union C equal to B union C, and A intersection C is equal to B intersection C. So we need to find which of the following is not correct, right? So let's say if A is a null set, right? If A is a null set, then what will be A complement? A complement will be what? Universal set, right? Because A is null set, so everything what remains is what? Universal set. So if it is a universal set, right? So can I say phi, which is A, is a subset of universal set, right? That is true. This is a correct statement, right? Again, if A is equal to X, A is a universal set, right? A is a universal set, then A complement will be what? Phi, right? Then phi is a subset of universal set. That is also correct, right? That is also correct, right? Then what they are saying, if A union B is equal to A union C, right? If A union B is equal to A union C, then B is equal to C, right? This is not correct, right? This is not correct. Why? Because if A union B is equal to A union C, then we can't say B is equal to C. Why? How? I'll explain this. Okay. Let's say A is this set, right? B is this set, right? And C is this set. Okay, B is this set and C be this set. So what will be A union B? A union B will be equal to A, right? And A union C is also equal to A, right? But B and C are not equal, right? B and C are what? Mutually exclusive. They are what? Disjoint. So they are not equal. So that is why we will say that this is the not correct option, which is in this case it is right. Right? This is in this case it is right. Okay. I hope this is clear to everyone. What is the right option for the first one? Right. Next, if A and B are two sets, then A minus B union B minus A union A intersection B is, right? A minus B union B minus A union A intersection B is what? Alright. So if you see here, I'll make, let's say, A, right? I'll make B. This is A minus B, right? This is A intersection B, and this is B minus A, correct? If I take the union of everything, if I take the union of all the things, what will I get? I will get A union B, right? I'll get A union B. So the answer is what? Option A, right? The correct option is what? Option A. Okay. I hope this is clear to everyone. Next, if A is the set of divisors of the number 15, set of divisors of number 15, B is the set of prime numbers smaller than 10, and C is the set of even numbers smaller than 9, right? Then A union C intersection B is equal to what? Okay, so let's first find out the set of divisor of the numbers, right? So A is what? A is 1, 3, 5, and then last at 15. Right. Now, B is what? B is a prime number. We are the set of prime numbers smaller than 10. So, set of prime numbers smaller than 10 will be how much? 2, 3, 5, 7. Right? That's it. 2, 3, 5, 7. They are the prime numbers smaller than 10. Let's find out C. C, they are saying set of even numbers smaller than 9. So, even numbers, I am not considering here 0, right? Because 0 is not there anyway, right? So, it is 2, 4, 6 and 8. 2, 4, 6 and 8. Now what they are saying? They are saying A union C. A union C. So what is A union C? Right? If I do A union C, this and this, I'll be getting 1, 2, 3, 4, right? 5, 6, 8 and then 15, right? 1, 2, 3, 4, 5, 6, 8 and then 15. And then we have to take intersection with B, right? Intersection with B. So if you see, if I take intersection with B, what is common between them, we will take it, right? Whatever is common between them, we will take it. So 2 is common, so 2 will be coming. 3 is common, 3 will be coming. 5 is common, 5 will also be coming, right? And then 7. 7 is not common, right? 7 is not common, nothing is common after it. So we can say that A union C intersection B will be equal to what? 2, 3 and 5, right? 2, 3 and 5. Alright, I hope this is clear to everyone. So the answer is what? Option C. Correct? Next. If C complement union D complement union E complement is equivalent to what? Right? C complement union D complement. Okay, so if you see, in everything there is complement outside, right? Everything there is a complement outside. So what I will do here, you should know that last time we have discussed De Morgan's law. So what is De Morgan's law? It says that A union B complement is equal to A complement intersection B complement, right? It says that it is A complement intersection B complement, right? So can I say from here that so if I take a complement of this, if I, let's say this is a set A, right? This is a set A. Set A be what? C complement union D intersection E complement, right? Then what will be A complement? A complement will be what? C complement union D intersection E complement, right? Now if I take this complement inside, this will become what? C complement intersection D complement, sorry, this will be intersection E complement, right? This will become nothing but C intersection, this will become what? D complement, intersection will become what? Union E complement, right? E complement, correct? So what will be this equivalent to? This will be equivalent to C intersection D complement union E, right? Union E, correct? This is what? A complement, but we need to find what? A. So what I will do, I'll just take complement of this. So if I take complement of this, what will I get? A is equal to C intersection D complement intersection E complement, right? Intersection E complement. So which option is matching here? I think it is option, so it is union. This is union. I'm sorry. This is union. So which option is matching here? I guess this one. Option C. Right? Option C is matching in this case. Right? I hope this is clear to everyone how to do this kind of question. Okay. Let's do the next one. Fifth question. Which of the following statement regarding is false? Right? Which of the following statement regarding is false? So A intersection A is equal to A. This is true. Right? This is a true statement. A union A is also equal to A. This is also a true statement. Correct. Then A minus B intersection C is equal to A minus B union A minus C. Right. This is an incorrect statement. This is a incorrect statement. Why? Because this will be actually equal to what? A minus B intersection A minus C. Right. This will be actually equal to this. Right. And what is this? They are also saying. They are saying A union B complement. A union B complement. See, A union B complement is nothing but A complement intersection B complement. So they have given this wrong. So this is the correct answer. Right? This is the correct answer because they are saying so the following statement regarding this set is what? False. So this is the in the set it is a false statement. Okay. I hope this is clear to everyone. Okay. Next, let C is equal to 1, 2, 3, 4 and D is equal to 1, 2, 3, 4, right? Then which of the following hold not true in this case? See, C and D both are equal sets, right? Equal. So C minus D is equal to D minus C. C minus D if I do, right? C minus D. Then I'll get null set, right? I'll get null set because everything is common. So I'll get null set is equal to null set. That is a true statement. Correct? If I do C union D, and C union D is nothing but C, right? C or D, and C intersection D is also what? C or D. This is also correct statement. Right? This is also correct. This is also correct. They are asking which of the following is not true, right? Then what they are saying? C intersection D is equal to C minus D. See, C minus D will be what? C minus D will be here 5. Right? C minus D will be what? 5. And C intersection D will be what? C. C or D, whatever, because both are same. So I will say this is the correct option. It means this one is not true. Right? This one is not true. Right? And C minus D is equal to 5. This is a true statement. Right? This is a true statement. Okay. I hope this is clear to everyone. Next, if A is equal to XYZ and B is equal to UVWX and the universal set is STUVXYZ, then A union B complement intersection A intersection B is equal to what? Then it is equal to what? So let's find out one by one. First, because we need to find out B complement, right? What will be B? A we know. A is what? X, Y and Z. B complement will be how much? Right? S, comma T, right? U, V, X is there, so Y and Z. Right? Y and Z. Correct? Now, if I take A union B complement, because that's what they're asking, A union B complement. So it will be equal to what? S, comma T, comma X, Y and Z. Right? This will be what? A union B complement. And then they are saying A intersection B. Right? A intersection B. What will be A intersection B? What is common between them? X is common. Right? So it will be what? X. Now, after this, what I have to do? Right? After this, we have to take intersection of these two. We have to take what? Intersection of these two. Correct? So if I take intersection X and X, what is the answer? Option B. Right? What is the option? Option B. Alright? I hope this is clear to everyone. Right? Okay. Next. 8th question. Let X and Y be two sets such that X intersection Y union X complement is equal to 5. Is equal to 5. Right? Statement 1 is that. And what is statement 2? If X union Y has M elements and X intersection Y has N elements, then the symmetric difference X delta Y has M minus N element. Has how much? M minus N elements, right? So let's understand this. I'll first explain statement 1, let's understand. X intersection, so if I draw it here, right, a Venn diagram. This is a Venn diagram, right? So X, let this be X and this be what? Y. Correct? What is X union Y? X union Y is nothing but everything. And this will be everything. But they want a complement. So if I want complement, this is what? Outside part. Right? This outside part is how much? X union Y complement. And now they are looking for intersection with X. What is X here? X is this. Right? Is there any intersection between the red part and the yellow part? No. Right? So it is equal to 5. There is no intersection between these two. That's why it will say it is 5. This is a correct statement. Right? Statement 1 is true. Now, let's understand statement 2. Right? For statement 2, again I will use Venn diagram here. If I use Venn diagram, right, for statement 2, if I use Venn diagram, right, this be X, this be Y, right, and what is X union Y? X union Y is nothing but this part, right. From this part, if I subtract this thing, right? If I subtract this part, so what will be remaining? The remaining part will be what? The remaining part will be this, right? And this, right? The remaining part will be this and this. So can I say from here that x minus y union y minus x, right? And that is, they have given it to be what? Symmetric difference. So this is also true, right? This is also what? True. So what can I say? The correct option for this is what? Option. Both statements are true, right? So both statements are true means what? This is the answer, right? Option A. All right. I hope I am clear for this. Then ninth question. The symmetric difference of sets A and B is symmetric difference. Okay. So we need to find out A minus B union. A minus B first we'll find out, and then we'll find out B minus A, right? And then we'll list all the elements, right? So A minus B. First we'll see what are the things which are not common, right? Or which are the common things. So 1 is common, 3 is common, right? 1 is common, 3 is common, 5 is common, 6 is common, right? 7 and 8. 7 and 8, right? So in A minus B, elements which are present in A but not in B will be coming. Correct? So what will be the elements in A minus B? It will be only 2 and 8. Right? It will be only 2 and 8. And in B minus A means what? Elements which are present in B but not in A. Right? Elements are present in B but not in A. So in this case, only one element is there, I guess. 9. Right? So it will be what? 9. Correct? This will be what? 9. So now what they are saying? They are asking symmetric difference. So A delta B is equal to what? A minus B union B minus A. So if I do that, I will get 2 comma 8 comma 9. Right? 2 comma, not 8, sorry, 2 comma 4. 2 comma 4 comma 9. So the answer is what? Option B. Right? 8 is actually common. So what is not common is 2 and 4. Understood? So answer is what? Option B. Alright. I hope I am clear with this one. Right? 10th question. This kind of question we have already done last time also. Right? What they are saying, let ui equal to 1 to 50 xi is equal to u n I equal to 1 to yi. It is equal to t. Right? Where each xi contain 10 elements. So total number of elements in T is how much? In terms of X, if I see, it will be 500, right? It will be 500. But in terms of X, we are seeing. If in terms of Y, if I see Y, so what I will get? N of T will be how much? It will be N into Y contain 5 elements, right? Y contain how many elements? 5 elements, right? If each element of the set T is an element of exactly 20 sets of Xi, 20 sets. So what I can say, 500 divided by 20 is the number of elements, right? Distinct. And exactly 6 of yi's. Exactly 6 of yi means it will be 5 into n upon 6. Right? 5 into n upon 6. Okay. So from here if I do, 5 will be cancelling out 5, 20 will be cancelling out 5. So this will go here. So n will be giving how much? 30. N will be giving us how much? 30, right? The correct option for this is what? Option D, right? Correct option is what? Option D, right? I hope I am clear with this. Okay. 11th, if an is equal to ax such that x belongs to natural number, bn intersection cn is equal to dn, right? Bn intersection cn are what? Cn, where B and C are relatively prime number. Relatively what? Prime number. Then what is the condition? Then what is the condition? Right? So see what they are saying, if An is equal to what? Ax is equal to Ax such that x belongs to n, and they have said B comma C belongs to are relatively prime. So let's take for example, let's write B equal to 2 and C is equal to 3. They both are what? Relatively prime. right? They are both prime number also, and they are what? Relatively prime also, right? Because relatively prime is what? Their HCFs will be 1. Here the HCF is how much? 1, right? It is correct. Now, right, what will be Bn? Bn means multiple, right? Bn means what? Multiple of 2. So if I do multiple of 2, I'll get what? 2, 4, 6, 8, 10, 12, so on, right? What will be Cn? Cn will be multiple of 3. It will be 3, 6, 9, 12, so on. Right? Now they want intersection. Now what they want? Intersection. So if they want intersection of Bn, intersection of Cn, it will be how much? 6 and 6. Right? Then 12 and 12. Right? So 6 comma 12. Right? And so on. Right? So this is nothing but they are saying it is equal to Dn. It is equal to what? Dn. Then can I say 6 and 12 are multiple of Bc, which is 2 into 3. They are multiple of 6, right? So from here I can say that D is equal to what? D is equal to Bc. D is equal to what? Bc. So the answer is option A. Right? The answer is what? Option A. Alright, I hope I am clear with this one. D is equal to BC. Now this is worksheet number 18, right? Before discussing, we'll be discussing it today, I guess, some of the question. Before discussing it, there is some theory which I need to discuss, right? So we'll do this theory first and then we'll be discussing the worksheet number 18, okay? And for tomorrow, I guess we'll be doing worksheet number 19. Let me start with the theory first. Note. Okay, so now this is very important part of set. Okay, what is that? Laws of algebras of set, right? Laws of algebra of sets, right? Laws of algebra of sets. Okay, now what is, first I want to explain to you what is n of s. N of s, let s be a set, then what is n of set? N of set, we all know it is what? Number of elements. Number of elements in set S. Right? Number of elements in set S. Okay. So now let's understand some few laws of algebra of set. So first one is what? That number of elements in A complement. Number of elements in A complement will be equal to number of elements in universal set minus number of elements in A, right? Number of elements in universal set minus number of elements in A, right? This is pretty simple to understand, right? This is A, correct? And this is U. So what is A complement? A complement is this part, right? And how will I get this? Number of element in U minus number of elements in A, right? So from there you can get number of elements in A complement, right? Second is very important, that number of elements in A union B is equal to what? Number of elements in A plus number of elements in B minus number of elements in A intersection B, right? Number of elements in A union B is equal to n of A plus n of B minus n of A intersection B, right? Now why it is coming, let's understand. This is a very important thing. So why it is coming, this is a very important formula. Let's understand. Okay. So let's say this is A, right? And let this be B, right? What this part is? This part is A intersection B, right? This part is what? A intersection B. We all know that, right? But what are we looking for? We are looking for A union B. We are looking for A union B. What is A union B? A union B is this whole thing, right? Now, when I add A once, right, number of elements in A, this A intersection B has already included. It was already what? Included. So this one, once it came, right? And then when I'm adding B also when I'm adding, this also part is also included, right? This part is also included, correct? But then this part, the middle part, is included twice. Is coming how many times? Twice. This part is coming what? Twice. So if it is coming twice, right, what can I say? Right, we don't need it twice. So we have to subtract it once. That's why we are subtracting it what? Once. Alright. So this is the theory behind how this formula comes, the proof of this, that n of A union B is equal to n of A plus n of B minus n of A intersection B, right? This is a very, very important formula. Please remember this. Okay, then third, n of A union B, n of A union B will be equal to n of A plus n of B, right? If A and B are disjoint set or what? Mutually exclusive. Are disjoint sets are what? Mutually exclusive. Why? Because if they are disjoint, it means that they have nothing common in them. If they have nothing common, so I can say that n of A intersection B will be equal to 5. Right? I can say that n of A intersection B will be equal to what? 5. So if it is 5, it will be 0. Right? This will be 0. So we can say this is equal to what? N of A plus n of B. Right? N of A plus n of B. Right? I hope it is clear for everyone. Next. Fourth. Right? Fourth what was? Fourth is n of A minus B. Right? N of A minus B. So let this be A, let this be B, right? Now we need n of A minus B, right? N of A minus B. Now what is A minus B? A minus B is this part. Elements which are present in A but not in B. This part is what? N of A minus B. To get this part, what I have to do, right? It can be also written as n of A intersection B complement, right? It can be also written as n of A intersection B complement, right? Now, how will I get it? I have to just subtract. A intersection B from. I have to subtract A intersection B from what? A, right? If I remove this part, which is n of A intersection B, I will be getting what? N of A minus B. Correct? Okay. Then, similarly, can I say n of B minus A will be what? N of B intersection A complement is equal to n of B minus n of A intersection B, right? N of B minus n of A intersection B. Correct? Okay. Then fifth part. Right? Fifth part. For fifth, we can say that n of A intersection B complement, right? N of A intersection A complement intersection B complement, right? This can be written as what? N of A union B complement, right? N of A union B complement. And what is N of A union B complement? It will be N of U minus N of A union B, right? From the first formula, I can say it is what? N of U minus N of A union B. Correct? I hope this is clear to everyone. Right? And sixth, N of A complement union B complement will be equal to what? N of, it will be equal to what? By De Morgan's law, can I say N of A intersection B complement, which will be nothing but N of U minus N of A intersection B, right? N of U minus N of A intersection B, right? Okay, so these are the 6 things for two sets. For 2 sets, these are the laws, right? Now we will be doing for 3, right? For 3 sets, right, for 3 sets. For 3 sets. So for 3 sets, what will I do? Right, this be A, this be B, and this be C. Right. So for these 3 sets, what I can say, n of A union B union C is equal to what? N of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C, right, plus n of A intersection B intersection C, right. This is very easy to understand. Okay, how it is coming, I'll try to explain you this, right. So let's select 3 colors. So let's say this is the part, this A intersection B, this be what? A intersection C, and this be what? Right, this be what? B intersection C, right, B intersection C, and the middle part, right, this part, right, this part is A intersection B intersection C, correct. So now, okay, to make you understand, first for n of A union B union C, I am adding all the part, right, for all the 3 circles, correct. So that's why we have added all the 3 circles, right. Now, but like in the 2 sets, we knew that this middle part, n of A intersection B, is coming twice, right. So we need to subtract it once, right. So how many middle parts will be there? Like this, there will be 3 parts, n of A intersection B, n of B intersection C, and n of A intersection C, right. So this 3, red, yellow and pink, right, we have subtracted it, we have subtracted this part 3 times because they were coming double, right. Now, but the middle part, that is a green part, right, when we added A, B and C, it came once, it came how many times? 3 times, right. This middle part, with A it came once, right, with B it came once, and with C also it came how many times? Once, correct. Now, when we are subtracting these parts, right, this green part is also subtracted twice, right. So we need this green part, right. So to get this green part, what we will do? We will add it once, right. This green part is nothing but n of A intersection B intersection C, right, n of A intersection B intersection C, okay. I hope this formula for 3 sets is very clear, right. So these are all the formulas for laws of set, right. There is one more you can say for 2 sets. For 2 sets, I'll write it here, that symmetric difference, that is n of A delta B is equal to n of A plus n of B, right, minus twice of n of A intersection B, minus twice of n of A intersection B, or you can also say it is equal to n of A union B minus n of A intersection B, right, n of A union B minus n of A intersection B, right. This is a, for 2 sets, it is also one more formula. These are all the formulas of laws of algebra of sets, right. Now we'll be doing questions on this, right. Now I'll be doing questions on this, okay. Now let's do the questions. Okay, so I'll take some examples. What are the examples? See, first example, in a group of 800 people, right, in a group of 800 people, 550 can speak Hindi, 550 can speak Hindi, right, and 450 can speak English. 450 can speak English, right. What we need to find out? We need to find out how many of them can speak both. How many of them can speak both, right? In a group of 800 people, 550 can speak Hindi and 450 can speak English. How many of them can speak both? Okay, Okay, so let's do it. So how will I do this? See, we'll say there are, how many people are there? 800 people. So if 800 people are there, I can say that, I can say that n of u is equal to what? 800, right? All the universal set, all the people will be coming in this set, right? Now, how many of can speak Hindi? So let's say n of h will be equal to what? 550. And n of English is equal to what? 450. Right? N of h and n of e is equal to what? 450. Right? Now, what are they asking? They are asking how many of them will be speaking both. So, for both, it means Hindi and English. And means what? Intersection. And means what? Intersection. So, let this be equal to x. Let this be equal to what? X. Now, let's understand, right? Let's understand. See, if any particular person out of this 800 people will be definitely speaking at least one language, either Hindi or English, right? Either he will be speaking Hindi, or either he will be speaking what? English. So can I say in this case n of u, right? N of u is nothing but n of h union e. It means number of people who are speaking either Hindi or English, right? Any of the language definitely he will speak, right? Correct. So we have this n of h union e, right? How much? It is 800. So we can apply a formula for this. What will be the formula? N of h union e will be equal to n of h plus n of e minus n of h intersection e, minus n of h intersection e, right? So this is how much? This is 800. 800 is equal to what? 550 plus 450 minus x. X is what we are actually looking to find, correct? So what I will do, this is 800 is equal to 900 minus x, right? So can I say x is equal to what? 900 minus 800, right? 900 minus 800, which is equal to what? 100. Which is equal to what? 100. Right? I hope this is clear to everyone. So number of people out of 800 who speak both will be how much? It is equal to what? 100. It will be equal to what? 100. Okay. I hope this is clear to everyone. Right? This question is clear to everyone. Okay. Then next example. Okay, what they are saying, there are 40 students in a chemistry class, right, and 60 students in physics class, Find the number of students right, who are either in physics or chemistry class. Physics or chemistry class, right? Okay, there are two cases in this, right? Which is the first case? In the first case, they are saying the two classes meet at the same hour, right? The two classes meet at the same hour. The two classes meet at the same hour, right? This is the first case, and the second case is two classes meet at different hours right, and 20 students are in both class. 20 students are in both class. Okay. So in this question, there is a slight difference in the two cases, right? What are the differences? Understand first. They are saying there are two classes, one is of physics and one is of chemistry, right? So can I say number of students in chemistry class will be equal to 40 and number of students in physics class will be equal to what? 60. Right, number of students in chemistry class is equal to 40, number of students in physics class is equal to what? 60. Right, am I clear? Okay, now find the number of students which are there in either physics or chemistry class, right? Which are there either in physics or chemistry class. So in physics or chemistry, what can I say? Number of physics union C, right? What they are saying, we need to find n of P union C. What are we going to find out? N of P union C. Now, in the first case, what they are saying, right? The two classes meet at the same hour. If the two classes are meeting at the same hour, right? Any one student cannot go in both the classes. Any one student cannot go in both the classes. If he can't go in both the classes, it means that I can say that N of P intersection C will be equal to 0, right? I can say that N of P intersection C will be equal to what? 0, right? And if it is the case, then what can I say? N of P union C is equal to N of C plus N of N of P, right? N of P minus N of chemistry intersection P, right? So what can I say here? It is equal to 40 plus 60 minus 0, right? Which will be equal to what? 100. Which will be equal to what? 100. So we can say that number of students who have enrolled either in physics or in chemistry class is equal to what? 100, right? It is equal to what? 100. Okay. Then next, the two classes met at different hours, right? They are different hours. And how many students are there in both the classes? 20 students are there in both the class. So can I say in this case, N of P intersection C is equal to 20, right? In this case, because the classes are at different hours. The classes are at different hour. Can we say that students can be going? There can be some students which can be going in both the classes, right? And that number of students is how many? 20. They have clearly mentioned here, right? It is how much? 20. So can I say from here that N of P union C will be equal to N of C plus N of P minus N of C intersection P, right? Okay, so it will be how much? 40 plus 60 minus 20, which will be 100 minus 20, which will be how much? 80, right? Which will be how much? 80. Alright, I hope I am clear with this one, right? In both the cases, the answer is different because there are some students in the first case, there is no students who can go in both the classes, but in the second case, there are some students who can be in both the classes. Okay, I hope this is clear to everyone. Now go to the next question, right? Okay, what is this question saying? Each person in a group of 880 can speak either Hindi or English, right? Either Hindi or English or both, right? If 55 can speak English and 40 can speak both, right? Find the number of students. Find the number of person. Find the number of person who can speak Hindi. Who can speak Hindi. Right? Who can speak what? Hindi. Right? Now what they are saying, each person in a group of 80, right? Each person in a group of 80 can speak either Hindi or English. So first of all, there is an information that n of universal set is 80 and it is also equal to n of Hindi union English. It is equal to what? N of Hindi union English, right? Because each person in the group at least speak Hindi or English, right? Now they have clearly mentioned out of this 80, 55 can speak English, right? What they have clearly said is 55 can speak English, right? And how many can speak both? N of, for both, it means Hindi intersection English is equal to what? 40. Hindi intersection English is equal to what? 40, right? What are they asking? They are asking what is n of h? What is n of h? Right. So for n of h, I can apply a formula. We know there is one formula. What is that formula? N of h union e. N of h union e is equal to n of h plus n of e minus n of h intersection e. Right. N of h plus n of e minus n of h intersection e. And it is equivalent to what? If I put all the values here, right, we need to find n of h. So let this be equal to what? X. This be equal to what? X. So I can say 80 is equal to x plus 55 minus 40. Right? 80 is equal to x plus 55 minus 40, and that is equivalent to what? 80 is equal to x plus 15. Right? X plus 15. So can I say from here that x is equal to 80 minus 15, right, which is equal to 65. 80 minus 15, which is equal to what? 65. Okay. I hope this is clear to everyone, right? This question, it is very similar to the first one what we have done, right? In that, I think again Hindi and English were speaking, but we need to find the common part, right? I hope this question is also clear to everyone. Now we'll be doing the next question. One more example, and then we'll be discussing some questions of worksheet 18, right? We'll be doing some questions of worksheet 18 today and a few questions tomorrow. Okay, so let's discuss one example. Okay, what they are saying, in a group of 65 people, right, 40 like cricket. 40 like cricket, right? 10 like cricket and tennis ball. 10 like cricket and tennis both, right? And how many like tennis? How many likes tennis but not cricket? But not cricket. And the second part is how many like tennis? How many like tennis? Right? How many like tennis? Okay, let's understand this. In a group of 65 people, 40 like cricket. Okay, so and 10 likes 10 like both. How many like tennis but not cricket? Okay, and how many like tennis? Okay, so they have not mentioned it here, but let's assume, right, that definitely in this group, at least in this group, right, every person likes at least one of the game. Every person likes at least one of the game. That is, he either like cricket or he either like tennis, right? At least one of the game he likes. So now, if it is the case, then what can I say? N of Q is equal to n of C union T. Right, this will be equal to what? 65. This will be equal to what? 65. Now what they are saying, cricket. How many of people are liking cricket? It is equal to what? 40. 40 are liking cricket, right? And n of C intersection T is equal to what? 10. How many are liking both? The number of people who are liking both is how much? 10. C intersection T is how much? 10. Now what they are saying, how many likes tennis but not cricket? This will find it later. But how many like tennis? So let's say n of t we need to find. This be x. N of t we need to find. This be what? X. If it is a x, right? Then what I can do? N of C union t is equal to n of c plus n of t minus n of c intersection t. Right? Minus n of c intersection t. Correct? Now what is n of C union T? It is 65. N of cricket is how much? 40. Right? Tennis we don't know. It is equal to what? X. Minus. This is what? 10. Right? This is how much? 10. So can I say 65 is equal to 30 plus x. So can I say x is equal to what? 35. Right, x is equal to 35 means that number of people who like tennis is how much? 35. Right, now what they are saying, how many out of these 35, how many out of this is 35 is the answer for this one. Right, 35 is the answer for this one. Now out of this, what they are saying, how many of these doesn't like cricket, right? They should like only tennis. Right, tennis but not cricket. So what I have to do for this, if you understand from Venn diagram, right, Venn diagram, let this be cricket, let this be what? Tennis. So they are asking this part, right, and we know what is tennis. Tennis is how much? 35. So to get this particular requirement, right, T, what I have to do, I have to subtract this intersection part from this whole tennis, right? So basically I need to find n of T minus C, which is nothing but n of t minus n of c intersection t. N of t minus n of c intersection t. So this is equal to what? It will be equal to 35 minus how many you are liking both? 10. How many you are liking both? 10. So we can say it is 35 minus 10, which is equal to what? 25. Right. So number of people who like tennis but not cricket is how much? 25. And number of people who like tennis is how much? 35. Okay, I hope this is clear to everyone, right? So we have completed the theory of set, right? Today's theory of set, right? And I think this is all the theory what we have to do. Now I'll be doing some questions of worksheet 18, right? For some time, and then we'll be discussing worksheet number 19 and some questions of worksheet 18 tomorrow. Okay, so let's discuss few questions of worksheet 18. Okay, though it was not in the homework part, but I have taken it. I have taken it here, so I'll be doing it here. Worksheet 18 there. So in this, what they are saying, if x and y are two sets such that n of x is equal to 17, n of y is equal to 23, and n of x union y is equal to 38, then how much is the value of n intersection? What is the value of x intersection y, right? So we'll apply the formula. There's one important formula I told you. What is that? X union y is equal to n of x plus n of y minus n of x intersection y, right? So what can I do here? I can write it, they have given this to be 38, right? This to be how much? 17, and this to be how much? 23, right? This we don't know. This we need to find, right? So we can find it. This is equal to what? 40 minus n of x intersection y. So n of x intersection y is equal to what? 40 minus 38, which is equal to what? 2. Right? 40 minus 38, which is equal to what? 2. And the answer is what? Option A. Right? The answer is what? Option A. Okay. I hope I am clear with this. Second, if x and y are two sets such that x union y has 18 elements, right? Number of elements in x union y in this case is how much? 18. Number of elements in x has how much? 8, right? And y has n of y is equal to 15, right? Y has 15. How many elements does x intersection y has, right? It is very similar to the previous one. I guess this you can do as homework, right? Or you can try it right now also. You just need to find x of x intersection y. It is very similar to the previous one, right? Same, just value they have changed, everything else is same, right? So I'll do the same thing. X union y is equal to n of x plus n of y minus n of x intersection y, right? This is 18 is equal to 8 plus 15 minus n of x intersection y. So I can say n of x intersection y is equal to 23 minus 18, which is equal to what? 5. Right? 23 minus 18, which is equal to what? 5. So the answer is what? B. Right? The correct option in this case is what? Option B. Alright? I hope I am clear with this. Okay. Next question. If S and T are two sets such that S has 21 elements, right? Number of elements in S is how much? 21. Number of elements in T is how much? 32. Right? And S intersection T, number of elements in S intersection T is how much? 11. Right? How many elements does S union T has? This time they have asking S union T. Right? So what I will do here, same formula, S union T is equal to what? N of S plus N of T minus N of S intersection T, right? So 21 plus 32 minus 11, right? So it is equal to 53 minus 11, which is equal to what? 42, right? It is equal to what? 42. So the answer for this is what? Option A, right? The answer for this is what? Option A. It's pretty simple, just value substituting case. You just need to remember one formula, right? N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay, let's do the next one. If X and Y are two sets such that X has 40 elements, right? X union Y has 60 elements and X intersection Y has 10 elements. Then how many elements does Y have? Right? How many elements does Y have? So what can I say? N of X union Y. Right? They have given directly to be 60. N of X they have given to be how much? 40. And N of Y. They have given to be how much? They have asked us. So let this be X, right? And N of X intersection Y is equal to what? 10. X intersection Y is equal to what? 10. Right. So what can I say? N of X union Y is equal to N of X plus N of Y minus N of X intersection Y. So it means 60 is equal to 40, right? Plus X minus 10, right? 40 plus X minus 10, right? So it is equal to what? 30 plus X, this is 60, right? So can I say X is equal to what? 60 minus 30, which will be what? 30. Which will be what? 30. So we can say it is option A, right? We can say it is option A. Okay, let's practice one more, last one, then we'll be doing everything tomorrow. Okay, now in this case, I have assumed that this is actually printing mistake. It is X union Y, right? This is a printing mistake. In this, it is what? X union Y. So what is, they have given N of X union Y, right? X union Y is given to be how much? 50. N of X is given to be how much? 28. And N of Y is also given to be how much? 32. So N of X intersection Y is equal to what? X, right? Let this be equal to what? X. We need to find it. So can I say from the formula N of X union Y is equal to N of X plus n of y minus n of x intersection y, right? So can I say from here 50 is equal to 28 plus 32 minus x, right? Which will be equal to what? 50 is equal to 60 minus x, right? So from here I can say x is equal to 60 minus 50, which is 10. So the answer for this is what? X is equal to 10, which is option 4, right? Which is option 4. Okay. All right. So let's stop it here. The remaining question we'll be doing it tomorrow along with worksheet number 19. For tomorrow there is no theory, so everything will be over. Tomorrow will be the last class, and we'll be doing worksheet 18 remaining question. I guess how many questions are there? Let's see. 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, right? 15, well, I think 10 questions from here, right? And worksheet 19. Worksheet 19, I think it's on page number, last worksheet of your CBC, okay? Yes, it also has 16 questions. So tomorrow we'll be doing everything, right? Tomorrow's homework is how much? Worksheet. Tomorrow there is a little more homework because this is the last class. So worksheet number 18 from 5 to 16, right? And complete worksheet 19 and complete worksheet 19, right? All the questions, right? It's on page number 82. It's on page number 82. Right, so we'll be discussing that tomorrow, okay? And tomorrow will be the last class. All right, thank you everyone. I hope you understood everything of sets, okay? See you tomorrow.